All right, everybody, welcome to Earth Science. Today we're going to talk humidity in the air. Like I'm holding some water in between my hands right now, but it's not a liquid, it's water vapor. So here's an Earth Science experiment that everybody has done. If you've gotten out of a pool, a bath, a shower, a pond, a river, a lake, a stream, whatever, a rainstorm, if your skin is wet and you feel that water start to evaporate off, what's the physical sensation that you feel? Think about it. Or go to the sink, put some water in your hand, shake it around a little bit so it evaporates. What's it feel like? I feel cold. So that might sound like a silly thing to say, but that premise right there is important in earth science. That when water evaporates, which is what these blanks right here are going to be, when water evaporates, temperature decreases or drops. Remember that. You've had that happen to you, probably in the last, maybe even day, maybe in the last couple of minutes. You felt water evaporate and you felt cold on your skin. In fact, it's the reason why humans sweat. This extra harder science idea. This is like experts a little tricky spot. If you don't understand what I'm talking about here, don't panic. No big deal. Evaporation and vaporization go hand in hand. So if we are vaporizing water, going from a liquid to a gas off of our skin, the water has to gain energy. And guess where it gets it? Out of your body. Your metabolic processes are keeping you warm, and evaporating water steals that energy from you. Which there's why we sweat. Humans have evolved sweat as a response to heat. If you get hot, your body sends water out the pores to wet your skin so that when that water evaporates, you cool yourself down. It's a premise called evaporative cooling. Which, it sounds like a fancy word, but it's just this, or it's just this. It's that when water evaporates, you feel cool. But somebody very clever said, you know what? I could use this idea to really figure out exactly how humid the air is. Because you can't tell. You can't like hold your thumb in the air and figure out what the humidity is. You can ballpark it. You know, on a very humid day that it's very humid. Think of the summertime when it's like oppressive and it's like a nightmare. You know that humidity. Maybe now this time of year, if you're doing this in January, it's very, very dry indoors. In fact, if you want to look down the road, you're going to have to tell me why it's very dry indoors in the wintertime. So maybe you have things like extra itchy skin. You notice, symptoms of it being very dry on your body. So let's consider these two scenarios because, again, you can't like just hold your thumb in the air and figure it out. How could we figure out using this idea of evaporative cooling exactly how humid the air is? We can do it, and it's actually deceptively simple. So here's some stolen internet clip art of what is clearly a very dry situation that's supposed to be a jungle, close enough, compared to a very humid situation. So, what the big differences are going to be? If I took a cup of water and placed it in both of these scenarios, all other things being equal, the two cups being the same, the water being the same, since it's very dry here and very humid here, which would you expect to have the water evaporate faster? I would guess, and if you guess this, you're right, that in this scenario, you're going to have more evaporation. In this scenario, you're going to have less evaporation. So if you really think about that, you can get down to like what's really super clever about what this guy came up with, or girl, I don't know who it was, honestly, to figure out how to measure humidity. They said that if it's very dry, that means there's going to be a lot of evaporation happening. And that means, since this is a thing, since this earth science experiment that you've experienced is a thing, that if there's more evaporation, there's also going to be more cooling. And if there's less evaporation, that means there's going to be less cooling. So what this very clever person did was say, I just measure how much cooling takes place with a thermometer, then I can, in a relative sense, tell if it's drier or more humid. And if you do that and you slap it together with a reference table, surprise, surprise, then you got yourself a way to measure humidity. So the key relationship to understanding all that, though, is that the drier it is, That means the more water will evaporate, which means that more cooling happens. Or if you want to say it the other way, the more humid it is, the less water evaporates and the less cooling happens. So what Mr. Clever or Mrs. Clever here figured out was if I take a thermometer and I put like a little bit of something to keep some moisture on the bulb of the thermometer, the bulb being the little knob at the end, and I then just spin it, water's going to evaporate. And if while it evaporates, I watch how much the temperature decreases, I can then figure out the humidity. Because if it decreases by a lot, it must be very dry in the room. And if it doesn't decrease by that much, it must be very humid in the room. And they put that all together, and some reference tables have been thrown together, and we now have a very simple way to measure the humidity in the room. So simple, in fact, that you're going to do it when you do the lab, kind of like with a bootleg version of one of these. You're going to take one of my classroom thermometers, tie some string to the end so that it can hold some water on the bulb, spin it, and see how much it goes down by. You do that, you're going to get yourself to an answer pretty easy. So let's like label the two parts of this. There is a dry bulb. That is a fancy term for a regular thermometer. Nothing special about it at all, other than it's dry. If it gets wet, it's not a dry bulb anymore, is it? And you're going to have, surprise, surprise, a wet bulb. And to accomplish that, you put a little bit of cloth or something around the bulb, get it wet, and then the goal will be to spin it and see how much it goes down by, and you got it. So this contraption, and this is definitely a question that is asked occasionally, is called a psychrometer. 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 That's a device to measure humidity. Specifically, and this is less of a concern, one that you spin, like with a handle, is called a sling psychrometer. Whatever on that. Psychrometer is the thing. Okay. Here in my classroom, if you've noticed it over there, next to the sink, there's a big yellow plastic thing with two thermometers in it. It's been there all year. Now we're figuring out what that is. It has two thermometers. One's wet, one's dry, and you use that. Excuse me. You use that to calculate humidity. So, and how it works is very simple. Again, get the wet bulb wet. Cool. Dry bulb must stay dry, otherwise it's not a dry bulb. Spin the handle. When you spin it, water evaporates. Like if your hand is wet and you go like that, you feel more cooling. You feel the water evaporating. And the key is to see how much did the wet bulb, I'm going to put this in capitals because it's important, go down by. That's the rub. That's where this thing works or doesn't work. How much did it go down by? So, for example, let's say it was 24 in the room right now, and I'm just making that number up, and it went down to 20. That number 20 isn't really important. If it's 24 and it went to 20, the number that's critically important is 4 because it went down by 4. That is where we're at. That's going to give us this new vocab word right here, wet bulb depression. The amount that the wet bulb dropped by. How much did it go down? Not what is it? And I'm promising over my many years of teaching regencies, and this is a sneak preview of what the reference table is going to look like. This is a screenshot, a clip from that reference table. This word right here has cost me many, many points on many, many regencies, and I would like to avoid that entirely for the rest of my career. This up here, this sentence does not say wet bulb temp, does it? It says something very different. It says difference between wet bulb and dry bulb temperatures. So take whatever you got for a dry bulb, which is plain old air temperature. Again, in my fake example, it's 24. If it went down to 20, it went down by 4. That would be the number we need. Now, 20 doesn't fit on that chart, so you might say, well, you no brainer, that's easy. But they will be mischievous and pick numbers that are on there, making sure that you know to do the difference. All right. We'll do all that to calculate the dew point, which is the temperature at which condensation occurs. Which is like if you've ever had a soda can in the summertime on days where it is very humid, this is easy to have happen. You get those like water droplets on your soda can. That is air, has water vapor in it. And that water vapor, when your soda can makes the air a little colder, that air reaches the dew point. So you got to have condensation. You got to have water go from a gas to a liquid, and that happens on that cold surface, right? Which is why you can't like put things on wooden furniture because you get that little ring and you get in trouble with your parents. That's condensation. It's earth science. Just say you're doing an earth science experiment. Get yourself out of trouble. So yeah, that's what it is. Anytime that you see water droplets forming on something, um, it's condensation. It's water vapor in the air already turning into a liquid because that thing made that air cool enough to reach the dew points. And speaking of that, the dew point must be lower. That dew point temperature, like this is just math. This is the only way it works. The dew point must be lower than the air temp. You can't have temp here with a higher dew point. It doesn't work. You'll always have a temp that's here, and that can decrease down to the dew points. And if things keep dropping, they drop together. But you can't have the dew point somehow get higher than the air temp in normal circumstances. You can disprove me with some college level meteorology high in the atmosphere, but we're not going there. In other words, you will always cool down to the dew points. All right, relative humidity is another. Go take some college level meteorology and come back and tell me how I'm all wrong on this. You're right. I am kind of oversimplifying here for the sake of making it understandable to this age level. It's like the percentage of water vapor in the air relative to the amount needed for condensation to occur. Now, that sentence, chances are, isn't going to make a whole lot of sense in your head. So don't panic about it. I'm really not worried about that definition at all today. Other than to say, like, okay, we're going to be figuring out what this relative humidity is. It's a percentage. If that percentage is really low, it's dry outside. If that percentage is really high, it's humid outside. If that percentage is 100%, condensation is going to be happening somewhere. If you're in like a steam room, you're at 100%. All right, so let's check out this ultra difficult, probably too advanced for this lesson sentence, but I'm saying it's deliberately too advanced for this lesson. And if we can like just throw it out there today and then slowly digest this for the next week and a half, then you're gonna make it. Life's gonna be good. And this is really what like all of meteorology is about as we get to it, as we get to how clouds form, as we get to how weather happens. It's this. So it's too much for today, but like let's throw it out there. If the air is cooled down to the dew points, that means that the air is saturated, which is a fancy pants term for full, totally full. If I went out in the rain with this shirt and came back in and it was completely sopping wet, every little bit of porosity in the shirt was filled with liquid water, I would say this shirt is saturated, totally filled. What that means then in like in air is that the relative humidity is 100%, which means that saturation can occur. Cool? If not cool, don't worry. That's like our goal for a couple of weeks. My big goal for today is going to be this big, scary looking reference table. We're going to try to make it not scary. Don't worry, it'll be fine. Um, if we can get through this by like next Wednesday, then great. That's the goal there. So this is like a little bit of like review. Are we really getting how this works? Can we review what I've done for the last 5-10 minutes, however long I'm forcing you to sit here? Right. If the wet bulb goes down by a lot, what does that mean? That means that okay, evaporative cooling is a thing. Things cool down as they evaporate, and if it goes down by a lot, that must mean that oh, it's very dry outside. So if things go, where are we? If the wet bulb goes down by a lot, in other words, what we've already learned, that means that it is very dry. Then the probability of precipitation, like the chance of rain, is going to be relatively low. Whereas if the wet bulb does not go down by much, in other words, not a whole lot of evaporation is happening, and not a whole lot is happening because it's very humid, then your probability of precipitation is going to be high. Oh, I said those backwards. Oh, did you catch me? No, I didn't. I did it right. Sorry. second guessing myself. If it's dry, it's going to be a low chance of rain. If it's humid, it's going to be a high chance of rain. Sorry, done this twice in a row. This is the third time, confusing myself. So if you had to describe a relationship, and I'm noticing a bit of gap in our ability to answer these relationship questions because earth science is stuffed full of them. As soon as you see describe the relationship or identify the relationship, which is frequent on our labs and on our tests, first word you say is as. And then you're going to compare the two things that they're asking you to compare. In this case, they want us to compare wet bulb depression to the probability of precipitation. So as wet bulb depression, then you would have a choice here. You could either say increases or decreases. The first two classes today said increases. It's answerable both ways, but pick one and then we'll answer the question. So as the wet bulb depression increases, how does that affect the other thing? The probability of precipitation. What do you think? As the wet bulb depression increases, that means that the wet bulb is going down by a lot. That means it's dry. That means your chances of precipitation are low, so it decreases. Cool. All right. All that said, here we go. Here's the goal today. Can you calculate dew points and relative humidities? All right. That's what my expectation by the time you're done with this. And this is because you were absent, right? That's why you're watching this video. I walked around in class to make sure everybody answered all these questions. There is no way to make it through the next like couple of things if you don't get how to do these. So let's tune in. What I'll probably do, I suppose, is a second video for the answers. I'd like you to try them, and then I'll throw an answer video up there too. So to figure out the dew point, here's what we're gonna do. The dry bulb temp is on the left. So please, right now, with your little cami marker, step one, dry bulb temp is on the left. So these are your dry bulb temps. Right down that column. You got from negative 20 all the way up to positive 30 in Celsius. And yes, they only give us the even numbers. Occasionally they'll be mean and do an odd number, which means you have to kind of like figure out how to do these in between two. It's a bummer, but it's not impossible. I'm going to give you all even ones as we're learning them. On the top is the wet bulb depression, or as we defined up above, the difference between wet bulb and dry bulb. That is this number. And then it's just a matter of see where they meet and include a label. I'm going to press pause and go see what my classroom thermometer says right now. All right, so over there on my psychrometer that I have on the cabinets, it says that the temperature in the room right now is 22 degrees. Again, plain old dry bulb temp is just air temperature. So what I would do here is say it's 22. And then the wet bulb temperature says that it's 13. Big mistake if you just go to 13 because this does not say wet bulb temperature. It says difference between wet bulb and dry bulb temperatures. So you would have to say, what is the difference? If it went from 22, I'll put these numbers up here just in case that helps. If it went from 22 down to 13, how much did it go down? Excuse me, how much did it go down by? It went down by 9 degrees. Step three, see where those two meet. Come down that column, come over that row, those two meet at 5. In other words, right now in this room, the dew point is 5 degrees C. There's your label. In other words, if I got something down to 5 degrees C, I should get condensation on it. That's it. What do you think? Can you do that on your own? Can you do that with these four? Why don't I start the first one for you, and then again, I'll do an answer video. And I beg, I urge that you check that video. Again, if you were in class, I would have checked all four of those. You got to be able to do these before you move on. If you move on to the next thing without understanding this, you're going to just get further lost and kind of waste more time and then have to come back to this anyway. So do this. Let's figure it out. What is the dew point? If the dry bulb is 18, step one, dry bulb is 18, and the wet bulb is 16. In other words, the difference between them, the difference between 18 and 16 is 2. There you go. See where those two meet. I won't do the answer right now. You can do it. And then do it 3 more times. Be careful here, there's negatives. You can use a calculator for arithmetic. I do. Because these negatives always trip people up, which is kind of why I put them there. If you go from 0 down to -4, how much did you go down by? If you go from 2 down to -2, how much did you go down by? Okay? Then, good news, bad news, whole new reference table to learn. That's the bad news. Good news is it works exactly the same. Put your dry bulb temp over here, put your difference at the top, see where they meet. All right? So, I guess, what the heck? We're all rookies. I'll help you out with the first one again. Dry bulb was 26. What bulb went down to 16? In other words, it went down by 10. See where 26 and 10 meet, and give me that answer. 2 bonus questions. If you're a pro, you can get those. If those are a little confusing, you can still be okay. This is a must do. These 4 and these 4. Bottom 2 bonus questions, we can deal with it. We can continue to practice. We can continue to learn. But the objective of this lesson is getting that down. If I said that enough, I think so. So do those, then watch the answer video, see how you did, and then we'll continue to practice. Thanks for tuning in, folks. So long for now.